Hi, I'm Vincent Hua.
Hi, I'm Meuser.
I'm Schneider. We're Solar Flare, and this is our project.
Okay, so the first part of our project was making a program that would help us collect the data for each solar trial we we're going to do. And the functionality of this is as follows. You're going to open Arduino runner final.m and you're going to run the script. And then it's going to pop up two windows. You're going to select the coordinate on the map that you're recording it for. And then that's going to go away and you're going to select the time of day, and there's instructions on the GUI, and then you're going to hit run Arduino. And assuming your module is plugged in correctly, it's going to begin taking 256 data points, and then it's going to stop, and you're going to take your circuit jumper off of it, and you're going to press enter, and it's going to store the next 256 data points into another variable. And then the last part of this is the manual data storage. Manual data storage is best explained on a desktop, so I'll give you an example of this entire process on a desktop right now. Okay, so like I said, you're going to first open Arduino runner final.m, and you're going to run it. And that's going to pop up two windows, the first of which is a map. You're going to select the coordinate that you're recording the data for, and then you're going to enter which time of day it is by 1, 2, or 3. Say, for example, 1 meaning morning, and you're going to do run Arduino. And then down here, it's going to automatically start running. It's going to list 256 data points. It's going to display remove circuit jumper, and you're going to remove the circuit jumper and press enter, and it's going to record the rest. After it runs these 256 data points twice, you're going to type in global X, Y, volt sweep, load sweep, and time of day. And what that's going to do is bring up all of these, it's going to reassign all of these variables in workspace. Lastly, you're going to assign the variables in workspace according to their the key that we made called location_key.pdf. For example, I'm going to store x and y into, if it's a first location, it's going to be L1C is equal to xy. And you're also going to you're going to go over here and you're going to right click. You're going to reassign load sweep to L1. If it was the morning, you're going to do M_1 for load sweep, and L1M_2 for volt sweep.
So now we're going to take a look at the code behind Arduino Runner. Before anything is even pushed, it opens a new figure for us to run G input on with the map of Davis, as you can see here. We make X and Y global so that way you can reach them in the workspace after the GUI is closed. Down here, after the button is pushed, we make our two variables, volt sweep and load sweep, global so they can be reached after the GUI is closed. We change the resistance, and then we essentially obtain the data using loops as n progresses, the position in our variable progresses, and that's how we record it. We make time day global so that way we can get it after the GUI is closed. After all the data points have been recorded, we condense them all to brainchild.mat. We just moved all the files together. And then after that, we wanted to move it to a more feasible variable, which we later named solar.dat3. And this is essentially how it works. We just collected x and y and moved those into one variable called location. And then pretty much what we did is we just said the first two columns for any location are going to be morning, the next two afternoon, the next two evening, and the next two after that are going to be averages. And this is essentially the code we used to use that, or to do that. We have a loop that essentially just transports the other variables and condenses them all together. And here we have the code that does column 7 and 8 just to average them together, so that way we don't have to do it in the actual GUI itself.
After opening the file project2 plots_out.m, this is our GUI. For plotting the morning data and maximum power points, we will just select them and select plot data, and it'll plot for us. And if we want to select a different time, like late afternoon data, we will just select late afternoon and plot the data.
from open circuit T.
And if we want to change the plot method to open circuit voltage, we will select that. And say we want to do the noon data, we will just select plot the data. And the code behind this GUI is as follows. So this is the if-then else statements for selecting the data for plotting on our GUI. A better visualization of this would be this. So for plotting on our GUI, if the user selects open circuit voltage, the variable t would be defined as 1. And for times morning, noon, afternoon, and average, the column A would be defined as 1, 3, 5, or 7. And if the user selects maximum power point, the variable t would be defined as 2. And times morning, noon, afternoon, average would be defined as A equals 2, A equals 4, A equals 6, or A equals 8. So for plotting our data, we used tri-scattered interp, where x and y are the coordinates, and z is a variable that corresponds to our type A or type t and a variables. We used a mesh grid for the dimensions of the map of Davis, and we contour plotted it with the line width of 1.5, and we plotted triangles to indicate the locations of where we collected our data.